Good morning, everybody. Good morning. Hello. Awesome to see that the lecture hall is filled with so many people on the last day of the conference. So we will start with our next keynote session. But before I will introduce our keynote speaker, I wanted to say that I hope that you have enjoyed the conference dinner last night. I also heard some rumors that a few people kept the party going quite well into the early hours of today. Looking over to you, Armin, as well. So now it's my pleasure and also my honor to introduce one of our keynote speakers, Professor Kou Murayama. Professor Murayama currently holds the position of full professor of educational psychology at the Hector Research Institute for Educational Sciences and Psychology at the University of Tubingen, Germany. In 2020, he was awarded the prestigious Alexander von Humboldt Professorship, widely regarded as one of Germany's highest honors in science, bestowed only to world-leading researchers in their field. He also serves as co-director of the Learning, Educational Achievement and Life Course Development LEAD Graduate School and Research Network. His journey began in Japan, where he earned his bachelor, master and Ph.D. in educational psychology at the University of Tokyo. He then collected national and international experience as a visiting and postdoctoral fellow at the Tokyo Institute of Technology, University of Rochester, UCLA in the US, and the LMU Munich in Germany. In 2013, he joined the University of Reading in the UK as a lecturer, rising through the ranks to an associate professor, and from 2018 he held a full professorship in psychology and cognitive neuroscience at the University of Reading. Simultaneously, since 2016, he has been an honorary professor at Kochi University of Technology in Japan. Professor Murayama's research seeks to unravel what powers human motivation, especially intrinsic motivation, curiosity, and reward learning, and how these processes support learning and educational achievement. His hallmark is remarkably interdisciplinary multi-method approach, merging behavioral experiments, longitudinal modeling, neuroimaging, ecological momentary assessments, educational interventions, computational simulations, and meta-analysis. Among his recent scientific contributions, there are papers on metacognitive monitoring in early elementary school-age children, detailing how they assess tasks differently depending on their context. Groundbreaking work showing that long-term learning performance in mathematics is more affected by motivation than by intelligence. A widely recognized study revealing that excessive parental expectations can negatively impact children's emotional well-being and learning outcomes, and recent publications exploring curiosity's neural, behavioral, and educational mechanisms, including work on metacognition of curiosity. With over 50 peer-reviewed articles, numerous book chapters, and commentaries across top journals like PNAS, Nature Human Behavior, Psychological Review, Educational Psychology Review, Psychological Science, and Cerebral Cortex, his influence in the field is immense. His work has garnered over 27,500 citations, and his age index on Google Scholar marks 68. His awards include the F.J. McGuigan Early Career Investigator Prize from the American Psychological Foundation, the International Mind, Brain, and Education Society Early Career Award, and the Transforming Education Through Neuroscience Award from the Learning and the Brain Foundation. Beyond his stellar academic accomplishments, Professor Murayama is known by colleagues as approachable and down to earth. Personally, I had the honor to meet Kou the first time at the joint conference of IMBES and SIG22 in Montreal 2020, where I was honored to invite him and introduce him as a keynote speaker as well. Since then, we've been in touch, and I can definitely confirm that the combination of rigorous scholarship and collegial warmth make him a very special person and a particular compelling keynote speaker. Please join me in welcoming Professor Kou Murayama as he shares with us the latest insights into intrinsic rewards, a key idea for motivation and self-regulation.
Thank you for the great introduction, Stefan. It means a lot to me. And I'm very honored to have a keynote presentation here in the EARLI conference. And I'm also glad to see many audience here, despite that this is the last day of the conference during the lunchtime. And I hope I can satisfy your curiosity today. And when I got an offer, I had two options to present my work. The first one is to showcase the broad set of work that I have been conducting. The other one is to focus on one simple idea, which I'd like everyone to know. And I decided to go with the latter. I hope it was a good decision, but you'll see. So today I'm going to talk about a simple idea called intrinsic rewards, which I believe is a key idea for motivation and self-regulation. So this talk is about rewards, but what are the rewards? When you look up the word into dictionary, then you can find the definition like something given in exchange for good behavior or good work, etc. This means that there are different types of rewards, such as monetary rewards, social appraisal, social recognition, tokens, awards, keynote presentation, and so on. But when you're a psychologist or educational psychologist, this term reward also activates another definition, which is rather peculiar, which is a stimulus whose presentation following a behavior increases the likelihood or frequency of that behavior. You should have learned this concept in the basic class of psychology. So this is the idea of behavioralism. Basically, reward is part of the reinforcement learning or reward learning. And you should know this scheme. Basically, in the reinforcement learning or reward learning, there's a conditional stimuli such as liver, and then an agent such as a mouse makes an action. In this case, press a lever. Then the mouse receives a reward, which is often a food. And by receiving a reward, the agent or the mouse actually had a rewarding experience, which reinforces the same behavior or increases the value of that action. As a result, when the mouse is in the same situation, then the mouse is likely to make that action again. This is the basic principle of reward learning or reinforcement learning, which many of you should be familiar with. And neuroscientific evidence repeatedly found that this process is related to so-called reward network in the brain, which includes striatum. The question that I'd like to ask in this talk is, do rewards work in education? When I ask this question to many education psychologists, the reactions are uniformly no way. Interestingly, when I ask this question to teachers or parents, actually quite a few people said yes, which is an interesting deviation, and I'm going to talk about that later. But there's a reason to believe that no way. Theoretically, reward failed to explain fundamental aspects of children's learning, such as intrinsic motivation, curiosity, etc. So kids can play without explicit extrinsic rewards. They just play around with various things, and this cannot be explained by extrinsic rewards. Empirically, people also found that rewards undermine children's autonomy. There's a famous phenomenon called undermining effect, in which giving extrinsic incentives would decrease the enjoyment of the task. So this is empirical evidence indicating that rewards actually harms educational processes. So the general statement among the education psychologists about reward is that rewards are bad in education, and reinforcing learning or reward learning is irrelevant in education. This is well represented by the book authored by Alfie Kohn titled Punished by Rewards. The goal of my talk is to make you reconsider this issue a little bit, or shed another light on this issue. I'm going to argue that the concepts of rewards and reward learning are crucial for understanding how children learn in classrooms. For that purpose, I'm going to expand the idea of rewards and introduce a rather new concept of intrinsic rewards as opposed to extrinsic rewards. And my main message is that children should generate intrinsic rewards through learning, and reinforcement by intrinsic rewards supports long-term engagement. The theoretical foundation of my talk has been actually described in some of the papers that I published in recent years. I listed these papers, and I'm going to give you a feel of the theoretical framework today. But if you are interested in the details of the framework, you can always read these papers, or you can always send me an email. I'm always happy to have discussions with you. I must also stress that the theoretical framework I'm going to put forth does not come out of vacuum. It's based on many foundational work by other excellent researchers in the field of motivation, psychology, neuroscience, and computational modeling, AI, and robotics. So the framework that I'm going to put forth is a kind of attempt to integrate these different lines of a theoretical framework into a coherent picture. This is the outline. I'm going to make 4 points, and I'm going to go through one by one. The first point is learning serves as intrinsic rewards. So I said that the intrinsic rewards are important, but what are the intrinsic rewards? Intrinsic rewards are the post-rewarding experiences learners experience, which are not triggered by extrinsic rewards such as money, social recognition, and so on. Or more, in a short term, it's a reward that are generated internally. Importantly, intrinsic rewards reinforce learning behavior or motivate learning behavior, meaning that intrinsic rewards are part of the reinforcement or reward learning processes. The concept is not super new. In education psychology, it's new, but in other fields like neuroscience, cognitive science, and artificial intelligence, people started working on this concept increasingly to make the model better and better. So it's really a hot topic in other fields, and I try to adapt this idea to the motivation theories in education psychology. So the question is, intrinsic rewards are important, but when are they generated? There are many sources. For example, when one achieves a goal, then you have a kind of feeling that I made it. And this is a kind of rewarding feeling, and this serves as intrinsic rewards. By achieving a goal, the person internally generates their own rewards, which would produce a positive feeling or positive experiences. Or personal appreciation, social interaction, personal validation, social interaction, all of these processes could produce internal rewards. But one of the factors that many researchers in cognitive science or AI have been focusing on is learning progress. Learning progress is a kind of progress in learning. When you learn something, you have a feeling that, oh, I made a progress, I learned new things. This is a feeling of learning progress, and many researchers in other fields repeatedly argue that this would actually produce internal rewards. In other words, the feeling that I learned something new or I understood it, this would produce intrinsic rewards, and then rewarding process or reinforcing learning process takes place. There is empirical evidence. For example, I try to, at the top, these are all neuroimaging studies. At the top, you can see that participants were presented with a blurred picture, and they didn't know what it is, but after a while, they saw the identity of the blurred picture. Then they have a kind of feeling of learning. Oh, I now learned that the identity of the picture is this one. And this feeling of resolution actually activated the reward network in the brain. In the middle study, participants were presented with trivia questions, and they were presented with the answer. They learned something new by the answer, right? Then the reward network was activated, indicating that this feeling of learning progress actually produced internal rewards. And at the end, you can see a numeric task. So basically, they did an arithmetic task. And when they worked on this and they made a progress about learning, this would activate the reward network in the brain, indicating that all sorts of learning processes are represented in the reward network in the brain, suggesting that reward learning is part of the process. I myself also conducted a neuroimaging study to see if these rewarding processes are the same rewarding processes as extrinsic rewards. For that purpose, I did an fMRI neuroimaging study and compared two conditions. First condition is food condition. So I just wanted to see the brain activation related to the food. And I knew that reward network would be activated by that. And in this case, participants are presented with a picture of the food, but they were told that they can decide whether they want it or not. And if they indicated they want it, then they can actually eat it after the experiment. So there's a kind of satisfaction of hunger here. And the other condition was quite tricky to me because I wanted to activate the brain area related to intrinsic rewards or curiosity or intrinsic motivation. And I decided to use rather peculiar stimuli, which is the magic tricks. We videotaped professional magicians in a lab and created a set of stimuli. So we now have a video clips of 100 magic tricks. If you are interested, it's uploaded online, and there are solution videos, and so you can also see the solution about it. But I'm going to show you two of them, just to give you a feel of what participants saw. I hope this triggered your curiosity to know the solution underlying it. And there's another one I can show you. I hope you can see it, but yeah, the Coca-Cola actually came out. And I hope this also triggered curiosity. What I said to participants is that after seeing each of the video clips, you have an option to see the solution behind the magic trick if they want. And so this way, they can expect the learning progress. They are going to learn the solution about the magic tricks. And we are interested in the brain areas related to this expectation of learning the solution. And what we found is that the same reward network in the brain is related to the expectation satisfying learning, satisfies curiosity and hunger, indicating that both extrinsic rewards and intrinsic rewards were processed in the same brain areas, indicating a common processing. So far, I have shown some ideas that learning serves as intrinsic rewards with some evidence. But you may wonder why we should actually, stipulate such a concept. For example, in motivation theories, you can find some similar concepts such as self-efficacy, control belief, and competence belief, which basically is a kind of feeling that I can do it. Learning progress is a little bit different in that it focuses on the marginal gain of learning. It's not the absolute level of confidence, it's rather how much progress you can make. In that respect, it's different. But more importantly, intrinsic rewards the concept of intrinsic rewards are important because intrinsic rewards can explain sustained engagement and self-regulation with a mechanistic picture, but I'm going to explain it. So the benefit of accepting the idea of intrinsic rewards is that we can explain the mechanisms underlying sustained engagement and segregated learning as reinforcing learning processes, which I'm going to explain in this slide, in the following slide. And this mechanisms is described as a reward learning framework of knowledge acquisition, which is a whole part of the paper that I presented earlier, and I'm going to give you a feel of it. So think about Albert Einstein. Many people agree that he's a person of curiosity. He was a curious person, and he was curious about so many things. And one important, remarkable aspect of his curiosity is that he was a curious person until the end of his life. He was really curious for many things until he passed away. And the question is, how is that possible? We can think of extrinsic rewards such as monetary rewards or social recognition. Of course, they partly explain his long-term engagement. That's no wonder. But at the same time, I don't think that's sufficient to explain his long-term engagement. What about other motivation constructs, such as intrinsic motivation, need for competence, self-efficacy, mastery goals, and so on? Many of these concepts say that if they have this motivation or these constructs are high, whatever they are, they can, persist. They can actually sustain long-term engagement. That's one explanation, but I'm not satisfied with it because it's a kind of tautology to me. You can sustain your engagement because you have intrinsic motivation, because intrinsic motivation sustains engagement. For me, it's not a mechanism. So we really need to understand the mechanisms underlying it. And your learning framework knowledge acquisition I'm putting forth is trying to explain it using the concept of intrinsic rewards and reinforced learning process. So to explain this, I come back to the original picture of the reinforced learning using extrinsic rewards. I already explained it. But one important thing is that to sustain the behavior, you need a constant input of reward here. Because once you provide a reward, it's consumed. The mouse eats it. Then you need to give another cheese, another cheese, another cheese. So in other words, you need a constant supply of rewards to sustain behavior based on extrinsic incentives. What would happen when we apply the same picture to the intrinsic rewards? It should look like this in the first place. So there's a kind of knowledge gap. So you have a feeling that, oh, I don't know something. I have a missing piece in my knowledge. This would prompt learning behavior. And after learning something, you acquire knowledge. In other words, there's learning progress here. And this learning progress actually serves as intrinsic rewards, which produce rewarding experiences and which increases the value of learning behavior through reinforcement. This way, we can think about how intrinsic rewards can reinforce learning behavior. But is that sustainable? Actually, we need to think a little bit deeper about it to make it more sustainable. And this is a critical difference between the rewarding processes of extrinsic rewards and rewarding processes of intrinsic rewards. What are the differences? Here, intrinsic rewards are knowledge acquisition. Knowledge is not consumable. Not unlike food. Once you eat it, it's not gone. It becomes part of your body. It becomes the flesh and blood of you. This means that once you acquire knowledge, you're going to actually expand your knowledge, which would be built up over and over again. And this knowledge is a key of how intrinsic rewards work. And there are different ways that this knowledge that we acquire have impact on this reward learning process. First, the more knowledge you have, the more questions you tend to have, which would actually make you realize another knowledge gap you didn't know before, which would prompt learning behavior. So the more knowledge you acquire, the more learning cycle it could happen. You may find it counterintuitive because I basically say that the more you learn about something, the less you feel you know about it. But you actually experience this many times. For example, I always use statistics because I like statistics a lot. But when you learn regression analysis, when a student learns regression analysis in statistics, some students just feel that, oh, I'm done. Yeah, that's true. But for some students, this would raise many questions, like how the partial correlation are different from regression coefficients, or can regression coefficients tell causality, and so on. The more knowledge you have, the more questions that you could produce, which would have been impossible before learning. Second process is this variation process. The more you acquire knowledge about the topic, the more value you can find in the topic. Again, using statistics as an example, when you first study psychology, education psychology, many of you would hate statistics because you never expected to study statistics in psychology, education psychology. But as you progress your learning, you just realize how important it is to learn statistics. In other words, accumulated knowledge actually increases the value of this statistical knowledge. And third path is this capability. The more you learn about things in a topic, the more you can learn about that topic. Again, think about the structured case modeling. If you just started learning statistics, you are never motivated to learn structured case modeling because you know that you cannot learn it. But once you mastered, or you feel you mastered regression analysis, you may have a feeling that maybe I'm confident enough to embark on learning structured case modeling. So this could also be another process by which this reinforcement process would be facilitated. So in sum, the more you learn, first, the more you realize how much you don't know. Second, the more you feel capable of learning new things, and the more you come to like the topic. And all of these processes work together to produce a kind of positive feedback loop. So knowledge acquisition creates a positive feedback loop that boosts rewarding experience over time. And this is how we can sustain intellectual engagement for a long period of time. This is what is happening inside Albert Einstein. People are generating intrinsic rewards in their mind, and the more you learn it, the more intrinsic rewards you can generate in your body, and then you can actually sustain your engagement. Some people complain that my picture that I presented earlier was too complex. So I try to make a simplified picture of the theoretical framework. So basically, there's a learning behavior, then you acquire some piece of information which gives you a learning progress, which gives you internal rewards, and internal rewards then reinforce the learning behavior, and there's a positive feedback loop between them. This is a kind of idea of the real learning framework of knowledge acquisition. Of course, this process does not always take place. If that happens, then we don't need teachers. So if you don't have an initial interest, you stay low because this process is never be activated. My point is that once this process is activated, this student has a bigger chance to actually have a long-term engagement over time. And as a result, sometimes this activation process happens by chance, but as a result, initial differences or small differences of interest may have a bigger impact over time, creating a snowball effect, a multiplier effect. It's not easy to empirically test the idea, but my first PhD student, Greta Fasslich, came up with a nice design to try to test this. In this learning experiment, participants are presented with many pieces of information about unknown countries or lesser known countries like East Timor. In this learning system, participants could click different pieces of information about a specific country. And importantly, after learning each piece of information, they also reported their interest in the country. This way, we can actually systematically examine the relationship between the amount of information, amount of learning, and interest. The design was rather complicated, but I'm showing the picture of one representative finding. Basically, when you focus on the countries with high initial interest, you can see the x-axis is amount of information learned, and the y-axis is interest. And as you can see, the more participants or learners learn about the country, the more interest they acquire, supporting the idea that there's a kind of positive feedback loop. On the other hand, when you focus on the countries with low initial interest, which should not activate the initial positive feedback loop, they stay low, and here the graph discontinued because they actually quitted the task there. So indicating that there's a kind of Matthew effect going on in this particular experiment. I also, after I came up with this idea, I also reanalyzed the data, which was collected for another purpose with Ayumi Tanaka, who should be in this audience here. So the paper actually assessed the students' interest of psychology class, but we assess them every week over 11 weeks. And we analyze the data for a different purpose. If you are interested, you can read this paper. But for the purpose of testing the idea of Matthew effect, I reanalyze the data using growth curve modeling. And I just plotted the growth curve of students with high initial interest and low initial interest. What we found is that at the beginning, of course, students with high initial interest and low initial interest are different. But the more important thing is that this difference gets bigger over the course of the weeks, indicating that there's a kind of Matthew effect, a snowball effect going on again. This is an interesting finding to me because according to the statistical law of regression effect, the differences should actually shrink, but it rather increased. So that was interesting to me. I didn't publish it, but I just wanted to do that for fun. Okay, so that's the main point of the theoretical framework. I'm going to switch the topic a little bit, which focuses on metacognition. We tend to metacognitively underestimate the power of intrinsic rewards. Here, I ask the question, do we know the power of intrinsic rewards? This is a question about metacognition, or more precisely, metacognition about motivation. We recently coined this metacognition of motivation as metamotivation. So I can call it metamotivation as well. So basically, metamotivation or metacognition motivation means that whether we can accurately monitor the power or current status of motivation. Why is that important? Because metamotivation or accuracy of metacognition is a basis to decide how to motivate learners or themselves. If we want to motivate other people, you should know what kind of things would increase the motivation. This is a metamotivation or metamotivation knowledge. And if this is inaccurate, you are going to use a wrong strategy to motivate other people. If you are familiar with cognitive psychology, learning, memory literature, you can see, you know the differences between blocked learning and interleaved learning. This is a good example. It's not a motivation literature, but it's a good example. So there are two types of learning strategies, blocked learning and interleaved learning. Blocked learning is also called a mass learning. Basically, they put together the same material and repeat this over and over again. Interleaved learning, on the other hand, actually interleave different materials. And many studies actually show that interleaved learning is very beneficial to learning over the blocked learning. I myself did some experiments with it, and it was quite robust, really robust. But when my colleague at UCLA, when I was a postdoc, actually asked participants to tell whether blocked learning actually benefited the learning. So she asked whether blocked learning or interleaved learning were better for their own learning. Most participants reported that blocked learning would have been, blocked learning was beneficial to their own learning. She actually tried to convince the participants for his entire dissertation, but she failed basically. So this means that people have a sometimes strong wrong knowledge, metacognitive knowledge about what kind of strategy would be best for your learning. What's the consequence of it? Because people believe that blocked learning is better than interleaved learning. People tend to use blocked learning when they are asked to study on their own. This is a problem. And the same thing could happen for motivation. So I try to apply this idea to the field of motivation, and this is a project called Meta Motivation of Intrinsic Rewards. Basically, I asked participants to work on boring tasks, super boring tasks, which include flanker task for 30 minutes without a break, delete is from 10 pages of text. Actually, these texts are my papers. And then the order was in alphabetic order, and etc. After this, participants were asked to report their motivation, or we also assess motivation behaviorally. So this is a typical motivation experiment, but I added a tweak to it. Before the experiment, we also ask participants to make a prediction of motivation after the task. So they got a feel of the task, then they were asked, so after you are going to work on it for 30 minutes, after 30 minutes, how would you feel? Can you make a prediction? By comparing them, we can actually see whether participants underestimated or overestimated their power of intrinsic rewards or enjoyment. This is a point of the experiment. As I said, there are many boring tasks, but basically, when I use different kinds of boring tasks, the majority of studies found that people enjoy boring tasks way more than they expect. I have to say that they are still boring, so at the absolute level, it's not super interesting, but still it is more than they initially thought. They initially thought, oh, it's going to be super boring. But actually, it is more enjoyable than they thought, because they were actually able to generate intrinsic rewards out of such a boring task. Or in other words, human has actually capacity to actually entertain themselves out of many different things. I actually did another study, which I didn't plan to actually talk, but now I can talk about it. But we also let people, sit in a dark room for 20 minutes. And then I asked them to make a prediction about their enjoyment after 20 minutes. Many people thought that that's boring because they don't have mobile phone. It's dark. They couldn't even hear. But actually, they enjoy this 20 minutes really way more than they expected, because they can actually imagine so many things in the mind, and it is enjoyable. Many people, reported different things. One student said that they were actually thinking about how to dance for 20 minutes. That time passed so quickly, so it was enjoyable, and so on. But they didn't know it in advance. That's the point. So they underestimate our capability to generate intrinsic rewards out of boring things, out of the things that appear to be not interesting. So intrinsic rewards may be underestimated when it comes to metacognitive prediction. In 2 of the experiments, we also gave rewards to participants. What happened is that when we said that, okay, we're going to promise some rewards for the task, they got excited. They said, oh, okay, so I'm going to get money out of it. So I have to be really excited to work on the task. So they make a high prediction about their motivation. But when you compare this with a no reward condition, actual motivation was not that different, indicating that people tend to overestimate the power of extrinsic rewards. That's a complete opposite from intrinsic rewards. So in sum, what we found is that we underestimate the joy of learning or intrinsic rewards. On the other hand, we overestimate the power of extrinsic rewards, which actually makes sense because extrinsic rewards are visible. You can immediately imagine what's going to happen to you when you receive it. On the other hand, intrinsic rewards, we cannot see it. So there's no clue to make a good prediction about it. But we have a capability, and this is something we should know. The question is, what do these findings mean? Why did I do that experiment? As I said, meta-motivation is a basis to motivate yourself. So think about a situation in which in which we want to motivate others. What are we inclined to do? Just remember that people tend to underestimate the power of intrinsic rewards and overestimate the power of extrinsic rewards. And then when we are asked to motivate other people, of course, we are going to use extrinsic rewards because we tend to overestimate the power of it. Many studies in education psychology found that intrinsic rewards are good. Intrinsic motivation is good. It predicts positive outcomes, well-being, good learning outcomes, and so on. But there's one mystery which has not been addressed. Then why should we still rely on extrinsic rewards? That's a mystery that we should address. Otherwise, we can't do a good motivation intervention. And there are many reasons, I have to say. But one reason which has been gone unnoticed for me is that people have a wrong belief of how incentives work in our motivation. And that may be why. So when we think about motivation intervention, of course, we need to focus on the intervention of students, on students, but at the same time, we should also pay more attention to the incorrect meta-motivation belief of educators and learners. So meta-cognitive belief is also another factor that we should intervene. I haven't done any intervention studies, but this is just a suggestion that I got from these studies. The last part is future directions. Actually, there are 4 future directions, so it's not short. But summary so far, rewards are not limited to rewards. I want to expand the concept. Learning progress serves as intrinsic rewards. Intrinsic rewards and reward learning framework explain the mechanisms of our long-term engagement, and we metacognitively underestimate the power of intrinsic rewards. I'm going to tell just 4 future directions, but they are my biased views, so you can always challenge me. Again, I like discussions. I strongly believe that discussion always advances the field. So feel free to get in touch with me when you don't agree with me. The first question, which is quite provocative in a sense, is that can we use extrinsic rewards to kickstart a positive feedback loop in learning? Again, at the beginning, I said that in education psychology, there's a kind of allergies to the concept of rewards or reward learning. And based on this, when I interact with some other education psychologists, the answer is negative. But I would say perhaps yes, but on a conditional, there's a condition to it. This is because intrinsic and extrinsic rewards are processed in the same neural system. This means that you can activate the loop with extrinsic rewards. As I said, without the activation, this positive feedback loop process never happens. If you don't learn, you don't start learning. You can never have an experience of learning. You never have an intrinsic rewards. You should first get on it. But many learners, stop learning or decline to learn before having this experience. So sometimes you need to force them to have this kind of experiences. But I'm not saying that you should keep giving extrinsic rewards. My point here is that once the loop is activated, maybe rewards are distracting. Then you can let the intrinsic rewards go. This kind of transition would be also important. And in a recent paper with Liz Varda, we call this a motivation transformation process, and we said that this is a kind of area of research which we should focus on in the future. We haven't empirically tested this yet, and we just call for more studies about it, because in the past, rewards are sometimes regarded as bad, but maybe there's a kind of compromise between these 2 perspectives. And you can see the figure here. At the beginning, extrinsic rewards can be dominated, but once positive feedback loop happens and the motivation expands over time, then the intrinsic rewards can occupy the larger part. And theoretically, this is a possible process. And I also have to say that although I say extrinsic rewards, when you give extrinsic rewards, actually it's not the rewards per se which motivate our behavior. Rewards actually give you information of how much progress you are making, right? So if you get the reward points, you can see concretely that how much progress you learned, how much progress you made in terms of learning. So it's not the rewards per se that had a motivating effect in my mind. That's a kind of information component of rewards that actually kickstarts the process. And this is also important to know. When we talk about rewards, some people just say rewards are bad. But you should not also dismiss the information part of it. Ed and Rich, so Ed Dish and Rich Ryan also talked about it. But when we discuss in a lower level, sometimes we forget about it. The second question is, can we unify motivation theories based on reward learning models? It's a broad question, and I know some great motivation researcher in the audience, so I hesitate to say, but I dare to say yes. And when you think about reward learning framework knowledge acquisition, you can actually see the pieces of it. For example, capability, this is a kind of self-efficacy, control belief, or self-concept. Also, you can see value belief here. And I also discussed in the paper, but when you think about learner who just follow this real learning process, this learner acts as if the person is trying to satisfy the need for competence. So for me, need for competence is a kind of emerging property coming from these real learning processes. In other words, real learning perspective provides more detailed process-level accounts of how such constructs function and emerge. And indeed, that's not only me who is doing this. Researchers in AI and machine learning are actively working to formalize these constructs. And we should also make an effort to actually be connected to these people. Then we should be able to do a better job. And one of the frustrations that I have had in the motivation theories in the past 10 or 20 years is that they are great. At the same time, they focus too much on constructs. Again, mastery goals, belief, value beliefs, expectancy beliefs, and so on. Of course, the theories are not about constructs, and I know this, but when it comes to empirical studies, they focus on constructs and computer correlation and see whether it's supported or not. It's an important work, but at the same time, we also need to think about the processes more, and this would be a way to actually make our field much more vivid and advanced. The third point that I would like to discuss is a stereotypical developmental view of curiosity and interest correct. What is a stereotypic developmental view? That is, young kids are full of curiosity, and we lose curiosity with age. Partly, that could be true, but it depends on how you define intrinsic rewards, engagement, and so on. That's a point that I would like to make. The missing piece of this stereotypic view is that knowledge is a driver of curiosity and interest. This is a hallmark of the framework that I put forth. Knowledge drives long-term engagement. According to this, the picture should be opposite. Young children may be more curious in terms of seeking novel things, but their engagements are often short-lived. They just jump around different things, and that's it. On the other hand, older learners have more knowledge. This means that they have more potential to sustain their engagement. So they are more likely to sustain long-term engagement or pursue knowledge deepening curiosity. I'm not saying that they are always like this. They have potential because they have knowledge, developed knowledge. We tested this idea using the data collected in Science Museum in London. We opened the booth and visitors can spontaneously stop by and play with a computerized game-like task. And one of the games that we provided is a kind of information-seeking task. And in this task, participants could select different topics. In this case, these are all mythical animals. And after selecting one topic, they have an opportunity to learn more deeper about the topic. So they are presented with different pieces of information about the specific mythical animal in this case. So it's similar with the task that I presented earlier. Actually, the author is the same. But with this task, we can differentiate two types of learning behavior. The first one is deepening knowledge. You actually focus on one animal and learn deeply about the animal. The other one is just going around different animals, but they just stop learning it after one or two pieces of information, shopping around it. And we plotted these strategies as a function of age, and what we found is that older learners prefer deepening their knowledge rather than shopping around for novel topics, and it's vice versa for younger adults. Here, blue bar represents learning strategies that aim to deepening the knowledge of a specific animal or topic. And red bar is a learning strategy to shop around different topics, but they stop learning about it after one or two pieces of information. As you can see at the beginning, when they're young, the red bar is predominant, but as they get older, it's the opposite, indicating that they have a different learning styles. So when we say whether curiosity changes, increases, or decreases with age? This is not a good question. It depends on how you define it. And because knowledge is complex, there are different ways of thinking about it. The last point that I would like to make is, can we use large language models to inform the reward learning framework? I decided to put these slides after walking around the early conference, actually, because there are so many interests about AI in education. There are many sessions discussing how AI can be used to, or can be undermine our education processes and so on. But all of these conversations are around how to use AIs or large language models to support learning. This is an important topic. So can we use AIs to realize adaptive learning? Can we use large language models to make our adaptive learning systems better? That's an important question. At the same time, I also would like to actually focus on different aspects of it. Can we also use LLMs to actually test theories? So LLMs can also be a new tool to empirically test theories. That's my way of using AI. And educational psychologists should be able to do this. And this actually has a great fit with the reward learning framework, because the main part of the reward learning framework is knowledge. But it's really difficult to quantify knowledge. We have vast amount of knowledge, and there's no way to quantify it. But LLMs have actually is a great window through which you can realize it. So existing knowledge may be quantified. So using text embedding methods, in my case, there are many other ways of doing it. But in my case, we decided to use text embedding methods. It's a part of large language models to quantify the knowledge structure. It's an ongoing project, so we're going to see how it works, but this is a basic idea. Imagine that you have a textbook, a whole textbook, science or mathematics textbook. Using large language models, you can actually project these texts onto numbers, basically vectors. And by applying some complicated statistical model, topic identification, topic network model, and so on, nowadays, you can actually create a kind of graph of knowledge that changes over time. That is, when you start reading the text, you have no knowledge about the concept, right? Then as you go through the text, the knowledge expands over time. You can quantify it using the text embedding vectors. And there are many different ways to do this. This way, we can actually imagine how people develop their knowledge network when they went through the textbook. Then we can also collect data about the engagement. You can get ratings, some eye tracking data, and so on. There are many different ways. And you can also compare how this subjective engagements or objective index of engagements are related to this knowledge structure, which are gained from the textbook. We did a pilot. Unfortunately, the postdoc at the moment declined to use textbooks, which I wanted to use because she was a big fan of Hunger Games. So she really wanted to test this idea using the novel Hunger Games. So that's okay. So maybe, it's a kind of entertainment novel, and I also read it, and it was quite engaging. And we basically applied that pipeline to the data, and then we also collected subjective report of their engagement. And I don't want to get into details, but first, we get some promising results. Second, this analysis pipeline has been accepted by the Association of the Computational Linguistics. So this means that our way of actually analyzing data should be quite robust enough for the experts, which is a good sign. So we are going to do this. And if we are interested in this kind of topic, I'm very happy to collaborate because this is the kind of topic I would like to pursue in the next years as well. So this is the last slide, I think, second last, but last slide, basically. So the last remarks, the message is that let's lift the mental barrier surrounding rewards and reinforcement in education research. Basically, rewards bad. There are some reasons for it, but when we expand the concept, we cannot deny the fact that when we enjoy learning, you can feel internal rewards. When you learn something, oh, that's That's true, yeah, it makes sense to me and so on. This is all rewarding experiences. And of course, this could reinforce your learning behavior. And maybe after listening to my talk, you have some sort of rewarding feeling, I hope. Then you may be motivated to read my paper. Then that's the best outcome out of it. But it's also reinforcement, right? So this process is something that we missed, but we should also think more about it. And it's also important that they open the door to connection with other fields. Why am I talking a lot about reinforcement learning or reward learning, which has been hated by education psychology for a long time? Because it's a common ground framework in other fields now. Neuroscience, AI, computational modeling, all of these people actually now use reinforcement learning paradigm or a kind of framework to describe human behavior. So there's an opportunity to actually join forces to have a great understanding human motivation processes. As long as we use our own languages, we can never get connected to these people. But by using this framework, we can connect the field of motivation, other concepts in education psychology, to the people in AI and neuroscience and computational modeling. This is a really great opportunity, I think. So to be interdisciplinary, yeah, this would be a great kind of starting point, I think. And then segregated learning is effortful and costly. You may be surprised to see the term segregated learning, which comes out of the blue sky. I just realized yesterday that self-regulation was part of my title, so I decided to put this statement because I completely forgot when I was making slides. Yeah, when I was making slides, of course, that's part of my mind, but I didn't talk much about it. But one thing is that self-regulated learning is really important for learning. And it's the next century skill for all learners. One important thing we need to recognize is that it's effortful and costly. Everyone knows it's important, but people don't do it because it's difficult. Sometimes it just takes time and making a plan. Why should I make a plan? I can just start working on it. So there are a lot of costs around it. This means that to sustain the behavior, sustain such a costly behavior, you need to think about how they can sustain this process. Here, you can think about intrinsic rewards. So by thinking about intrinsic rewards, you can also think about the important aspect with self-regulated learning. Again, we are super clear that they're important, but now one of the missing pieces is how we can sustain this costly behavior, costly but important behavior. And reward learning may be one aspect that we could contribute. And last is a kind of big point, but think more about theories. You might find that my talk was rather theoretical, not many empirical studies. As I said earlier, I did that on purpose. But one point I would like to emphasize is that there are many empirical studies, but I think theories is something that we should focus more in the future. In the early conference, I can see that the boundary between practitioners and researchers are getting smaller and smaller, which is a good thing. But then we need to think, what makes us research? What is the strength of being a researcher? The boundary is getting less and less. We need to think about the identity as a researcher. And there are many answers. But one important thing is that we need to sharpen our theoretical views. This is something that practitioners, of course, have, but researchers should have more. And by deepening our theoretical insight, we can contribute to the education together with practitioners. So theory is important. And I'm going to conclude my presentation by just reading out the expert text from my paper that is cited here. Educational psychologists are investing too much time in applying and testing existing theories and not enough in articulating and developing theories. But to promote good empirical work, good theories are imperative. If a theory is not well specified, the empirical testing that follows the theory can be strongly misguided, which may result in a waste of resources. Currently, the field offers limited incentives, especially for young researchers, for developing extending theories. There are unfortunately many more outlets for empirical papers than theoretical papers. But we do encourage researchers to have more active discussions about the theories themselves. And that's the end of my presentation, and I'd like to express strong acknowledgement to my team members, research assistants, students, and postdocs who actually worked together to make the projects possible that I presented today. I also express deep thanks to my mentors, collaborators, and colleagues who actually developed my career. As indicated in the introduction, when I wrote a dissertation, I got a PhD in a small island country in Far East Asia called Japan, which is not that international. And I wrote a dissertation in Japanese. And I didn't have any international publications at the time. I only have publications in journals, Japanese journals, whose impact factor is 0.1 or 2. So if you are planning to write a dissertation, you are already well ahead of me. But all the mentors, collaborators, colleagues encouraged me to pursue an international career, including Reinhard there and many other collaborators in the audience. I really appreciate their support. Without their support, I wouldn't be here. Thank you very much.
Thank you very much, Kou. It's always impressive to see the progress of your work and the expanding of your knowledge base from one talk to the other. That is really, something to, amazing. We do have time for questions, obviously, and I see already a couple of hands rising up, so maybe...
For this intrinsically motivating speech, you create a very optimistic picture of human learning in your framework, right? And I agree with most of your basic propositions, but I would still have one question. It can happen that interest, enjoyment, intrinsic motivation decline even if there's growth of knowledge, right? And your own data show that. The longitudinal studies we're having on adolescents' intrinsic motivation show that. Top-level experts after decades may lose interest in what they have learned, right? How would your framework explain this darker side, this, of negative growth, right, that can also happen?
Thank you, Reinhard. So in all the papers that I presented, I listed some factors that actually undermine these reward learning processes. But this is just a starting point. And I want to start from positive. And then we can think about how this framework cannot explain the actual current status of motivation in the classroom. So this is the next stage of questions in my framework. I call it framework, not theory or models, because I know that it's not enough at the moment. So I'm hoping to actually do more work about it in the future. It's a hand-waving answer, sorry about it, but I really want to work on it.
Thank you for the presentation once again. So it seems to me that throughout the whole presentation you have this assumption that learning new material always brings joy, right? You have it. So my question is, what do you think about the topic? Whether effects would be different depending on the topic? Because, for example, learning about, let's say, science may be very different from learning about genocide. What do you think about that?
So it's clear. So one important thing is that learning progress is defined against the knowledge that you have. So basically, the same topic could trigger interest or learning progress, feeling of enjoyment for some people, but not for other people, because they have different knowledge base. And when the learning material is presented in a way that would actually facilitate learning progress for this particular person, this would trigger positive experiences. But if you don't know much about the topic, then you never have a learning progress experiences, because you don't have a knowledge base to understand it. So the point here is that there are different differences between the domains, and actually we are working on it. The point here is that these domain differences and individual differences can be understood how each individual learners developed their knowledge before reading this learning material. So we really need to think about the history of learning of each individual to really understand the motivation processes.
Thank you, Kou, for your inspiring presentation. I was wondering about the necessity of knowledge acquisition to come to intrinsic rewards. For example, I give dancing lessons to adults. They have knowledge gaps, they experience them, and they show learning behavior. But some of them, of course, will never acquire certain knowledge, and they still, as far as I can tell, experience intrinsic reward just by simply having the learning behavior. And still they would have this sense of learning and the joy of learning, which feels rewarding and makes them persistent in showing their learning behavior. So do you think knowledge acquisition is a prerequisite in your model? Framework?
One of the main sources. I actually skipped quite quickly, but there are many sources for intrinsic rewards, and this talk focuses on learning progress because I still feel it's a major source of it. But there are other sources, and one important thing that I would emphasize is actually the role of the social processes. When you see someone enjoying learning mathematics, you somehow actually have a kind of vicarious learning intrinsic rewards by looking at your friends. And so indeed, when you look at the recent AI or robotics literature, they also started focusing on social processes to actually make the AI learn better. So social processes is also one critical factor when you think about intrinsic rewards. When you see someone working on it, you can infer that this person is enjoying it. This must be an interesting thing, so I should do this, even if you haven't learned it before. And this is also another important source. And there are other things, goal achievement, personal values, yeah.
Thank you very much for your inspiring work. I have a question that is related to the other one. Do you consider learning progress subjectively or also objectively? Because when you look at the cognitively oriented research, you have concepts like desirable difficulties where you make it harder for students to have them better learning outcomes in the end. And when I understand you correctly, you argue in the other direction that making it more rewarding is better to sustain engagement. So would you equate subjective and objective learning progress and also consider these aspects? Thank you.
Yeah, it's a good question, great question. I haven't had a good answer to it because it's a kind of discussion in the field as well, of AI as well, but I would say it's a mixture of it. And I also have to emphasize that could be also automatic process. You may not subjectively aware of the learning progress intrinsic rewards in some extent. For example, when you look at the robotics literature, what they actually call intrinsic rewards is robot has an arm and grasps a ball, but when you move this way, you are closer to the target. And they call it learning progress, but we never sense it in our mind. But our body actually, implicitly processes this learning progress and calculates every time. So it's a mixture of it. Are they qualitatively different? Maybe. So this is something we need to work on. Yeah. Thank you for a great question.
Thanks, Kou. My question is around the role of interest, which you've shown is really large. The role of interest is really large. And I kept thinking about interest the whole talk. For example, when you show the Science Museum study where adults show more specific information-seeking behaviors, I wondered if it was because they have more interest, so they can sort of start searching for information and derive pleasure, where kids are just sort of clicking around. And it made me think, well, I've always bought this idea of positive reinforcement, learning progress. But before that, there was the idea of a knowledge gap. And I wondered to what extent we understand what the knowledge gap might map onto interest. And if you can show kids that there's a gap in their knowledge, you can kickstart this positive reinforcement loop. I don't know, I wondered whether there are neuroimaging studies on interest and whether they've been shown to be activated by knowledge gaps. Yeah.
Yeah. for the first question, it's quite true that older adults had more interest in many topics in general, but this is because they have knowledge, about the world better than younger kids in general. So it's part of the hypothesis kind of prediction. So that's true. For the neuroimaging studies of interest or knowledge gap, interest, so basically here by interest, I mean enduring interest, individual interest. So people have a stable feeling of engagement over a long period of time. It's really difficult to examine using neuroimaging, right? Because neuroimaging study only focus on an experiment in one session. So, but actually this is an opportunity. Education psychologists are interested in long-term development. Neuroimaging people are working on short-term curiosity, temporary, momentary activation curiosity. How can we combine? For example, I haven't conducted it, but I'm trying, I was, for example, dreaming to do a study to track the same participants, like 2 or 3 participants, over a year using neuroimaging. I actually scanned my student for 3 months and every day. And I want to extend this for a long period of time to see this long-term development process of interest. And so there are no studies at the moment, but this is opportunities that education psychologists can participate in the future. Yeah.
I guess the bigger question is how do you get children who don't have interest?
Mm-hmm. Yeah, okay, so that's all. How can you kickstart the positive feedback loops process? Of course, like other motivational theories, I can only say a general thing. Knowledge gap is one thing. So basically, you just need to get them on the learning. Let them just work on the learning task in the first place, and you can, as I said, extreme rewards to work, but you can also present a learning material which actually triggers knowledge gap to people. The problem here is that knowledge gap is also defined against existing knowledge. So knowledge gap is different among different learners. So you need to have a great assessment of the existing knowledge before actually thinking about it. That's a challenge, I think.
Thank you for your presentation, Kou. Could you comment on intermittent reinforcement of intrinsic rewards? I didn't hear anything of that during your presentation, but we know from, I don't know, a century of research that intermittent reinforcement is very powerful. So could you comment on that?
Can you elaborate this a little bit?
Well, we know that from probably thousands of studies based in more behaviourist frameworks that intermittent reinforcement is very...
Okay.
Yeah, does that clarify?
So you mean partial reinforcement or intermittent?
I suppose I do. The intermittent reinforcement meaning that you are not reinforced on every single trial.
Yeah.
So I'm wondering if any of your research has used intermittent reinforcement schedules, or if not, what would you predict an intermittent reinforcement schedule of intrinsic rewards to produce? Would it simply be the same, or would you expect anything different?
That's a great point. So my understanding is that intermittent reinforcement or partial reinforcement can make the reinforcement resistant to the extinction. So this actually helps us have a stable value representation in the brain. And I think this is important thing. And I haven't given great thoughts to this curiosity literature, but actually I thought about it in terms of the effort. So effort is also a reinforcing process for me. And there's also a great theory paper, Learned Industrialness by Eisenberg. But basically the idea is that effort is costly, but sometimes people become conscientious. Why? This is because if you make an effort, sometimes you get a positive feedback out of it. Sometimes not. But actually this partial reinforcement nature of effort and outcome relationship actually shapes our conscientiousness. And I'm quite convinced by that idea. There are not so many empirical studies about it, but this reinforcement idea actually can also speak to another aspect of interest, which is, again, conscientiousness. So yeah, that's a great comment, and yeah, I'm going to think more about it in terms of the curiosity as well.
Okay, Thank you, very wonderful and very interesting talk. Yes, I'm here.
Sorry. Okay. Sorry.
Sorry. Yeah, this talk significantly increased my intrinsic motivation to ask questions.
The best reaction. Thank you.
Yes, I am wondering about the link between extrinsic motivation and intrinsic motivation. It's like, for example, especially from the perspective of kids, like, I don't know what this kid is interested in, right? And some parents, they try to guide the interest of the kids, so they give something like the kids like. And for example, if you can study for like 10 minutes today, I will give you something you like. So in this case, I don't think it's like a very like big difference between extrinsic and intrinsic motivation. So I was wondering, I want to hear your thoughts on this, like this, the link between these concepts, especially from a developmental perspective.
Yeah, I completely agree. I think at the beginning, there's an undifferentiated concept of intrinsic and extrinsic rewards for kids. That's my also personal feeling. And as I told in the presentation, when we give extrinsic rewards, there are different meanings. First, it's rewards, but second, it also gives you a signal about the progress, or also it gives you a sense of, self-esteem and so on. And all of these things actually, different aspects of rewards cannot be well recognized by kids. So sometimes kids just perceive this as a signal of learning progress. That's why there's less differentiated relationship between intrinsic and extrinsic rewards. But as we get wiser, we know that now rewards are more than just a signal of learning progress. It could, signal that you are a great person, or it could signal that your mom is actually trying to control you and so on. Then as we get wiser, the implication of rewards get complicated, and this is how the idea of extrinsic and intrinsic rewards, the distinction between them gets more salient. So I agree with you, and I think this is because extrinsic rewards actually include so many elements actually.
A question over on the right side of yours.
Okay. Yeah.
I was wondering about intrinsic and extrinsic reward. So, in my understanding, motivation is this what gets us things done, and it's not more like extrinsic or intrinsic motivation, but more about the reward if it's intrinsic or extrinsic. But would you really draw a line between intrinsic and extrinsic reward? Because we are always in exchange in surroundings, and if there's a line, where would you draw it? On the skin, or where is it?
Yeah, at least I don't think there's a hard distinction between intrinsic and extrinsic rewards. And there are rewards, many different types of rewards. I said social recognition, appraisal, and prizes, and so on. They are different rewards. And at the end of the psychological processing, it's actually processing the reward network in the brain. But at the same time, I want to emphasize that at the upstream of the process, they are different. Money and social recognition looked quite different. At least you can see social recognition. Then, money is processed in the visual area. And of course, social recognition is not processed in the visual area. So there are differences between the rewards, and then some properties of a reward actually make reward processing quite peculiar or idiosyncratic. So people tend to use an easy category like intrinsic and extrinsic. But actually, when we think about rewards, we actually need to think about the processes of motivation for each different types of rewards, rather than the dichotomy of intrinsic and extrinsic. So yeah, it's just a big, rough distinction, but I'm not big fan of it.
Thank you. Well, as we talk about intrinsic and extrinsic rewards, I have another question. Let's imagine that we have a learner who is motivated through internal rewards, mostly, okay? Do we expect that this learner will keep being engaged in an activity And I'm wondering, I'm asking this because learning process and knowing could be a curvilinear situation. Therefore, there is a moment that you are learning too much and you are high because you're rewarded internally. But at some point, when you know a lot, you're expert in this domain, maybe learning decline because there is not too much to learn. You are expert. And if you base your motivation only to internal rewards, I'm wondering if this can make you to switch to another discipline, another field, another subject in order to have again this high situation of internal rewarding. And therefore, I'm wondering if it's good to base students' motivation or learners' motivation only to internal rewards. If this is a kind of addiction that it's not really good for engagement, I'm wondering. Yes, this is, because we need also a competence, to develop a competence to internalize extrinsic rewards in order to keep engagement.
Yeah.
This is my point.
So I had a similar discussion with Suzanne Healy on Monday. And so this is part of the special issue Suzanne actually edited. And so basically this picture indicates that at the end of the day, you don't need any extrinsic rewards at all. You just let the intrinsic motivation go and then we should be happy. In reality, it's not that simple. You know, sometimes learning progress stops because, you know, you have a kind of plateau of learning or you have so many other things going on and so on. So this is again an optimistic view about how motivation develops. But in reality, you actually need some, you know, fuel from extrinsic rewards, like giving a keynote again here. And, you know, these kind of things actually make you, you know, work better and better. So it's important that, you know, we actually to emphasize that this is just the ideal picture of it, but in reality, it's more complicated. And people sometimes may want to switch the topic, but maybe this has a cost because learning a new topic, actually you need another knowledge base. If you don't have any knowledge, then there's no basis to develop interest in the first place. So yeah, whether it's wise to switch another topic is another question, but yeah, at least I can say that what you said is really convincing to me.
Hi, thank you very much for this talk. I was wondering whether in your framework you considered also the expected reward and then the actual outcome, because that's kind of what all the reinforcement learning theories have. They have the prediction error, and I was just wondering whether that's already included or you've thought about including this, because I guess it could explain many more. It could make many predictions and explain many behavior.
So in the original paper, 2019, I included the expected reward and actual reward and included kind of prediction error kind of things. Because basically, if you realize that, oh, I learned more than I thought, or I enjoyed it more than I thought, this would be a positive signal for further learning. So I agree, yeah, that's part of it. I omitted at some point because it was a little bit too complicated for education audience. So, but in my mind, what you said is part of the framework that I presented.
Thank you for your presentation, and it's very inspiring and fascinating. And I just try to understand correctly about your model. So it took me some time, like, to think about, is it actually a real, actual knowledge acquisition or a perceived knowledge acquisition? But after reading your paper, so my understanding is it sounds like a more inclined to an actual knowledge acquisition. But so I'm just want to clarify. So if it's an actual knowledge acquisition. So where perceived knowledge acquisition should be located in?
Yeah. So this is a similar question with the one that I asked before. So is that subjective or objective? And I don't have a clear answer to it. It's a mixture, I'd say. And the field has been debating about it. And also it depends on what kind of learning we are talking about. If it's about perceptual learning, yeah, maybe actual learning progress. But if about learning from complex text, maybe subjective learning, because you can never quantify objective learning in your mind. So yeah, it depends on the learning materials. And this is something that we should work on.
Yeah, and it also reminds me of another like Einstein slides with 3 points. So the second point is, so the more students learn, the feel capable of
subjective, right?
So I'm also thinking whether they feel more capable or they are actually capable of.
I think it's more subjective. Many self-efficacy or control value theory, or, expectancy value theory focused on more subjective part of the confidence. So I'd say this capability part is subjective.
Okay, thank you. This is my question. Thank you.
Good. I'm afraid I think we need to end this session. Thank you very much for engaging in this lively discussion that has been very, very interesting. And I'd like to thank Kou again for coming to Graz to the EARLI conference and for giving this keynote. Please join me in a round of applause.